Okay, in this video we are going to talk about fraction sense. I have uploaded this document onto week 11 if you would like to print it out, but these are the problems we're going to go over during this video. Okay, so fraction sense is just understanding fractions, understanding how you can compare them, how you can order them, just everything that's not like operations with fractions. So the first thing we're going to talk about is equivalent fractions. This was on your last test. I just want to go over it one more time because it's super important. So we're wanting to show that 1/2 is equivalent to 2/4, is equivalent to 3/6, is equivalent to 6/12. So I can do that with pattern blocks, I can do that with a set model, I can do it with a number line or Cuisenaire rods. So let me just do that with pattern blocks. So this is number 1 with pattern blocks. So if I want to show that 1/2 is equivalent to 2/4, is equivalent to 3/6, is equivalent to 6/12, then I need to start off with a whole. I'm going to use my whole as the hexagon here. So there's my whole. If I wanted to show 1/2, I would split it into 2 pieces and shade one of them. So that would be 1/2. 2/4, my whole's still the same, it's still the yellow hexagon. I'm going to split it into 4 pieces this time, shade 2 of them. So that's 2/4. And these are the same amount of area shaded on each one. So they're equivalent fractions for 3/6. Draw my yellow hexagon again. This time I'm going to split it into 6 parts, which in this case is green triangles. I want to shade in 3 of them. It's still the same area, so they are equivalent. And then 6/12 would be same whole. This time I'm going to split it into 12 pieces and shade 6 of them. So let's see if I can do this. So that's 12 pieces. Not super great, but did my best. Shaded in 6 of them, so 6 out of 12. Okay. So the next problem, so you could do this also with Cuisenaire rods. It'd be a little bit more difficult with Cuisenaire rods because you need to start off with the 12 and show how you can split it into different ones. You could also do a set model, start off with 12 dots, shade in half of them, and show 2 groups, shade in half of them again, but show it's 4 groups, 2 are shaded, 6 groups, 3 are shaded, 12 groups, 6 are shaded. Okay, so let's move on to the next problem. The next problem says name a fraction between 2/6 and 3/6. So I need to find some fraction in between 2/6 and 3/6. So thinking of a fraction in between 2/6 and 3/6, I guess you could think, well, if I still wanted to keep my 6 on bottom, what's the number between 2 and a 3? 2.5, but that's kind of yucky. We don't want to do decimals within fractions. Or 2.5. 6 is a fraction within a fraction, which is even worse. So instead, let's, since I don't have a number of parts in between 2 parts and 3 parts, let's split our whole into a different amount of parts. So instead of 6 parts, let's split our whole into 12 parts. So let me draw a picture of this, and that might help a little bit. So if I was going to draw 2/6, let me use my yellow hexagon again. So if I wanted to draw 2/6, I'm going to split my whole into 6 parts, shade 2 of them. 3/6 is splitting my whole into 6 parts, but this time I'm shading 3 of them. Okay, so since I don't really have a piece that's in between 2 pieces and 3 pieces, let me make my whole different. Not my whole, let me make my parts different. Okay, so instead of making this into 6 parts, let's make it into 12 parts. So this is using the purple triangles. So I didn't change my whole. I didn't actually change the amount of area shaded. I just changed the parts that I'm using to measure it. So this fraction becomes a new fraction. It's the same fraction, an equivalent fraction, but this time I have 1, 2, 3, 4 pieces shaded. 12 make a whole. This time I have over here 1, 2, 3, 4, 5, 6 pieces shaded. 12 make a whole. And now I can find a number or a fraction in between 4/12 and 6/12 because 5/12 is in between 4/12 and 6/12. 4 pieces shaded, 6 pieces shaded, I could have a fraction that's 5 pieces shaded, and that's in between the two of them. Okay, so if you need to find a fraction in between two fractions and there's not a whole number in between those two whole numbers on top, you can change your denominator, like change your parts. So you can do that with a picture, or if you didn't want to draw a picture, another way to do it for 2/6 and 3/6 is you can multiply by a number on top and on bottom. In this problem, we multiplied by 2. You could actually multiply by any number. Like here, let me do it with 3. When I multiply the fraction on top and bottom by 3, I get 6/18. Isn't 6/18 equivalent to 2/6? Yes, they're equivalent fractions. And 9/18, isn't 9/18 equivalent to 3/6? Yeah, because they're equivalent of fractions. Well, now I have some options. What's a number in between 6/18 and 9/18? Well, I have 7/18. I also have 8/18. Okay, so both of those are answers. All 3 of these are correct answers. There's not one specific correct answer to this problem. The number of fractions in between 2/6 and 3/6, there's actually infinity fractions in between 2/6 and 3/6 because I can multiply by 3 and get 2 fractions right there. I can multiply the top and bottom by 4 and get 3 other fractions. I can multiply by 5 and get 4 other fractions, so on and so forth. Okay, so there's not a single right way to do it. Most people just usually multiply by 2 or maybe 3 and pick one of these fractions here. Okay. So the next problem we're going to go over is name a fraction between 1/2 and 5/8. So a similar problem, this time my denominator's not the same here. Up here I had a common denominator 6. Here I don't. So let me do that problem now. So a fraction in between 1/2 and 5/8. So there's a couple different ways you can do it. You can draw a picture if you wanted to. I don't really want to draw a picture for this because if I'm using like my yellow hexagon again, I can't really split it in 8 parts, and I don't really want to do a rectangle or a circle or anything in 8 parts. So instead, let me just kind of do it over here with the multiplying numbers here. So a number between 1/2 and 5/8. First, we need to kind of think like, is 5/8 bigger than 1/2? Is it smaller than 1/2? So a way to think through that is, let's make these have the same amount of parts. This one has 8 parts. 8 parts make a whole. I have 5 parts shaded. This one has 2 parts make a whole, 1 part shaded. So let me get my number of parts to make a whole the same. I can turn this into 8 parts first, right? So I can not multiply by 8, multiply by 4, because 4/8 is equivalent to 1/2, right? So now I'm comparing 4/8 to 5/8, or like trying to find a number in between them. So now this is similar to the problem above it. Okay, so 4/8 and 5/8, a number in between it. I don't really want to do 4.5/8, so let me take both of these numbers, 4/8 and 5/8, and make them into more pieces. Instead of 8 pieces make a whole, let's multiply both the bottom and the top by 2. And now 16 pieces make a whole. So 16 pieces make a whole. Half of it would be 8 pieces, because 4 times 2 is 8. For 5/8, 16 pieces make a whole. 5 times 2 is 10. And 5/8 and 10/16, 4/8 and 8/16 are equivalent fractions. So now it's easy to find a number in between 4/8 and 5/8. It's a number in between 8/16 and 10/16, which would be 9/16. Okay, so a fraction in between 4/8 and 5/8, or 1/2 and 5/8, would be 9/16 would be your answer. Okay, so if you'll look at the next problem, number 4 is number 4 and number 5. Well, 4 and 6 are both ordering fractions from greatest to least, least to greatest. And there's a couple ways we can do it. So if you look at part A, those 3 fractions, 1/5, 4/5, and 3/5, those all have the same denominator. So we do that problem one way. If you look at B, 5/6, 5/31, and 5/12, those all have the same numerator but different denominators, so we do that problem a little bit different. And then if you look at number 6, I left off the problem there. I'll write it in here and I'll update the one you'll print out. So the one you print out should have these numbers, the fractions on there. These don't have a common numerator or common denominator. Okay, so I'll write those in just a few minutes. And let me do that right now real quick. So let's put in order the fractions. 13 out of 14, so 13 fourteenths, 1/5, 25 26, 13 over 22, and 15 over 31. So you already have those on your paper. Sorry about that. Okay, so let's start off with number 4 and do part A and part B. So number 4, part A, we want to put these in order from greatest to least. And my fractions I have is 1/5, 4/5, 3/5. Okay, so this is the easiest of the problems because they have a common denominator. So for all of these fractions, 5 parts make a whole. Okay, so if 5 parts make a whole, this one has 1 part shaded, this one has 4 parts shaded, this one has 3 parts shaded. It's pretty obvious which is the greatest one. 4/5 is the greatest fraction because 4 is the greatest number, right? So 4 is bigger than 3, 3 is bigger than 1. So that means that 4/5 is my biggest fraction. That's greater than 3/5, which is my next biggest fraction. And that's greater than 1/5, which is my smallest fraction. Okay, so you would need to explain this some way. You could draw a picture of 4/5, 3/5, and 1/5 using any model you want to, area, set, line model. You could explain in words, 5 parts make a whole, 4 pieces is bigger than 3 pieces is bigger than 1 piece. It doesn't matter, you just need to explain it somehow. Okay, so explanation, 5 parts make a whole, 4 parts is greater than 3 parts, which is greater than 2 parts. Nope, 1 part, sorry. So it's 1/5. Okay, for part B, 5/6, 5/31, 5/12. Yeah, 5/12. Okay, so I want to put these in order from greatest to least. Okay, so this one's different. The numerator's the same for all of these. So this means that 5 parts, I have 5 parts, or I was given 5 parts for all of these fractions. The difference is what makes a whole. So 5/6 versus 5/31 versus 5/12. So if you needed to draw a picture here, I'm going to do my hexagon, and I'm just going to do 5/6 and 5/12 and just kind of show you the difference between those two. So 5/6, I need to split my whole into 6 parts, shade in 5 of them. 3, 4, 5. So that's 5/6. 5/12, split my whole into 12 parts, shade in 5 of them. So it'd be 1, 2, 3, 4, 5, like this. Okay, so it's pretty obvious that 5/6 is a greater fraction than 5/12. And the reason why is because 5 parts is shaded on both of them. It's just since my whole is only split into 6 parts here, each part is bigger than here my whole is split into 12 parts, so each part is smaller. So when you have the same numerator, the idea is all have the same number of pieces. The difference here is the smaller the denominator, the bigger each piece is. So the bigger each piece is, which means the bigger the fraction is. Okay, so if I wanted to put these in orders from greatest to least, the biggest fraction would be 5/6, because splitting my whole into 6 pieces, that's the biggest pieces versus 31 pieces and 12 pieces. So 5/6 is my biggest fraction. My next biggest fraction would be 5/12, because if I split my whole in 31 pieces, that's going to be tiny little slithers here. And here 12 is going to be bigger pieces. So 5/12 is the next fraction if I'm doing size. And then the smallest fraction would be 5/31, because each piece would be tiny and I'm only shading in 5 tiny pieces. Okay. So you can use this explanation, or you can make it more specific. I'll have 5 pieces and then use 6, 12, and 31 to explain it. Okay. Look at numbers. Let's go ahead and do number 6, and we'll come back to the other one. So for number 6, fraction benchmarks. Okay, so when I don't have common numerators or common denominators, a way to order fractions is to use fraction benchmarks. Okay, so a benchmark is like telling you how close to something you are. So if you'll read the directions, it says, first put the following fractions in one of the 3 groups, closer to 0, closer to 1/2, closer to 1, and explain which group you put it in. Okay, so I have 3 groups I can put them in. Closer to 0, closer to 1/2, closer to 1. Okay, and each fraction I'm going to put in a group. So I'm going to start off with 13/14. This says my whole has 14 parts. I have 13 shaded in. So what would that be close to? Would that be close to 0, close to 1, or in the middle, close to 1/2? Well, 13/14, that's almost all the parts shaded out of a whole, so that would be close to 1. So 13/14 would be close to 1, and my reasoning is because it is 1/14 away from a whole, from 1. Okay, and next fraction, 1/5. Well, 1/5 is 5 parts make a whole, only 1 part shaded, so that would be the opposite. That would be closer to 0, because I only have 1 out of 5 shaded. So 1/5 is closer to 0, and my reasoning here is because it is 1/5 away from 0. So by putting them in the categories, I'm kind of already putting in order from least to greatest. I mean, I'll have to do a little bit more work at the end probably, but obviously 1/5 is smaller than 3/14. Okay, so my next one, 25 out of 26. That's going to be closer to 1 also, because same idea. 25 out of 26, it's because it's only 1/26 away from 1. Okay, so 1/26 away from 1. 13 out of 22. Well, if I have 22 pieces make a whole, 13 out of 22 is close to 1/2, because, so I'm going to put it in here, 13 out of 22. It's close to 1/2 because 1/2 of 22 would be 11. So it is actually 2/11ths bigger than 1/2. Because, I'm sorry, 2/22. Sorry about that, 2/22. Because 11/22 is 1/2. And 13/22 is 2 pieces bigger than 11/22. And then the last one I'm comparing, 15 out of 31. Where would 15 out of 31 fall? Well, 31 pieces make a whole. It'd be like 15.5 would be the middle. So 15 out of 31 would be close to 1/2 also. So 15 out of 31. And this is actually 0.5 pieces smaller than 1/2. Okay, so now I did the first part. It says benchmark them, put them in one of the 3 groups, and then put an order from least to greatest. So to put these in order from least to greatest, closer to 0, then closer to 1/2, then closer to 1. So 1/5 would be my smallest fraction. Okay, the next fraction up, it's either going to be 13 over 22 or 15 over 31. Let's think through which one's going to be the smallest one. Well, 15 over 31 we already wrote was smaller than 1/2, and 13 over 22 is actually bigger than 1/2. So 15 over 31 would be your next fraction. And then 13 over 22 would be the next one. Okay, so now these last two, this is like, I feel like this is the hardest part of this problem. I'm comparing 13/14 to 25 over 26. Okay, so both of these, so both are 1 away from the whole, right? The difference is if I split my whole into 14 pieces, those pieces are bigger than if I split my whole into 26 pieces, right? So this 1/14 away from the whole, that's actually a bigger piece than this right here. So like, since this is a bigger piece that's not shaded in, because that's what's not shaded in because it's that much away from a whole, right? This is actually going to be the smaller fraction. 13/14 is the smaller fraction. Okay, so 13/14 is the smaller one than 25 over 26. And like the idea here, if you needed to draw it, it's hard to draw 14ths and 26, but let me see if I can do it. Let me do something that's a little bit easier. What if it was like 11/12 and 23 over 24? So these are two different fractions than that, but the picture, it's easier to draw the picture this way. So that's 6, so 12. Uh-oh. Man, I really messed up this picture. Let me start that over again. Let's do a hexagon because that might be easier. Maybe I'll do a better job with hexagon. So if I was doing 12ths, there we go, that's a little better. That would be a picture of 12ths. And 11/12, it's everything shaded in except for one piece, right? So I'm going to leave that piece open right there. And these should all be equal pieces. Mine aren't perfect by any means, but it's got to be better than that one, right? Same thing if I did 23 out of 24. Let me do the hexagon again. I might do a little better job. So this time, so that's 12. Now 24s, I need to split each of those in half. So these are tiny little slithers of pieces. And I hope that this is making sense. So if I'm leaving one of those open, it's a smaller area that's still open, right? So this is the smaller fraction, this is the bigger. Because this is shading in more area, because my piece that's left open is the smaller piece. Does that make sense? I hope so. Sorry about my scratch drawings here. Okay, so that's the reason why 13/14 is actually smaller fraction than 25 out of 26, because the piece that's left available is different sized. Okay. Okay, so last couple things on this paper, number 5 and number 7. I'll also fix this on number 5. I just realized we're naming a fraction between 0 and 1/10 with a numerator not equal to 1. So this will be corrected on your paper also. Okay, so this is similar to 1, 2, and 3. To number 2 and number 3. So I want to name a fraction between 0 and 1/10. So something between 0 and 1/10. Well, I could write 0 as a fraction if I wanted to. It's kind of silly, but it helps a little bit in this problem. 0 is no parts shaded in out of however many parts you want. So 0/10 and 1/10. Okay, so I want to write a fraction in the middle of 0/10 and 1/10. The difference with this problem is I don't want to use a numerator of 2. I'm sorry, a numerator of 1. So if I were to do this problem like I were doing earlier, 0/10, 1/10. If I multiplied both the bottom and the top by 2, I would get 0 times 2 is still 0/10. 1 times 2 is 2/10. And the fraction in between these is, this is 20ths and 20ths. And the fraction in between these is 1 out of 20. Well, the problem said don't do a fraction with a 1 on top. So take a second and see if you can think of how to do this problem where my middle number is not a 1 on top. if you think about it, think back to number 2 when we did it. I did it 2 different ways. I did it like this, and I did it where I had 2 different options here. So let's do it like that. Instead of multiplying by 2, let's multiply that by 3 like we did here. Okay, so I'm going to take my same fractions, 0/10 and 1/10, and this time I'm going to multiply them by 3 on bottom and on top. So when I multiply them by 3 on bottom and top, I still get 0 out of 30. On the bottom one, I get 3 out of 30. Okay, so I have 2 fractions available here in between 0/30 and 3/30. And the 2 fractions are 1/30 and 2/30. So I can pick either one of those. I don't want to pick the 1/30 because remember the problem says don't have the numerator of 1. So I'm going to use 2/30. So 2/30 is a fraction in between 0/10 and 1/10. And that would be your answer. And that's not the only answer. There are more answers. You could multiply this by 4, you can multiply by 5, you can multiply by 6, and you'll get different numbers here, but they would all be correct as long as they don't have a 1 on top. And the last problem we're going to talk about is using a picture to represent the following 3 scenarios. Okay, so scenario number 1, or part A, Joe grew 3/4 of an inch last month. Okay, so if I wanted to draw a picture of growing 3/4 of an inch, like I don't necessarily need to draw a picture of like somebody actually growing that. I just want to draw a picture of 3/4 of an inch. The easiest way to me to do is on a number line for this one, because usually we measure things using a number line anyways, a ruler, right? So 3/4 of an inch, if this is 1 whole inch, if I wanted to draw 3/4, I would split that into 4 pieces. This would be 1/4, this would be 2/4, this would be 3/4. So 3/4 of an inch would be like that. Okay. For part B, it says 4 kids want to share 3 pizzas equally. How much pizza does each get? Okay, so I'm going to draw 3 pizzas. So here's 1, here's 2, here's 3 pizzas. If 4 kids are going to share this, I need to split all these pizzas into 4 parts. The easiest way in my head to do it, you may think differently than me, but it's to split each pizza into 4 parts. Because then kid number 1 gets that piece from each pizza. Kid number 2 gets this piece. Kid number 3 gets this piece. And kid number 4 gets this piece. So how much of a pizza does each kid get? So let's just talk about kid number 1. Kid number 1 gets this piece, and this piece. How much pizza is that? Well, if this is my whole pizza, he gets 1/4 from this one. If this is my whole pizza, he gets 1/4 from this one. If this is my whole pizza, he gets 1/4 from this one. So 1/4 plus 1/4 plus 1/4 is 3/4. Okay, you can do that a couple different ways. That's just the way that I thought about it. And then part C, 12 people are in the room, 3/4 of them are women. Okay, so let me draw 12 people. 2, 3, 4, 6, 7, 8, 9, 10, 11, and 12. So there's my 12 people in the room. If 3/4 of them are women, so 3/4 are women, that means I need to split my whole room into 4 parts. So here's 1/4, 2/4, 3/4, 4/4. Which one are women? Well, 3 of those groups are. So let me put little hair on them or just label them, it doesn't matter. So these are my women. Okay, so I just wanted to show you like the reason why we have the 3 different models. We have a number line or a line model, an area model, and a set model. And here's like 3 examples of how we think about things differently. Like each of these were 3/4. 3/4 of an inch, 3/4 of a pizza, 3/4 of a set of people or women. It's just we use different models to explain it. So that's why it's important to make sure you teach each model in your classroom, because all three models come up in real life. I feel like lots of people shy away from the number line model just because lots of us are not comfortable with number lines, but it's so important for students to understand number lines that I'd encourage you not to shy away from the number line just because that might not be something you're comfortable with.